We are going to explore sound chapter. Yes, we are going to discuss about sound, about this. Here, I would like to tell you what points, what points will be discussed in this. That is what I wanted to tell you first of all. We will understand meaning of a sound, types of a sound, points related to sound, propagation, re- there are a lot of there are some important words that we need to understand. I will tell you meaning of those words with a definition. Now we are going to start with word production of a sound. It is clearly telling you to produce a sound. What will be production? To produce a sound, what will be production? Can you tell me, are you able to hear sound right now? I would say yes, you are able to hear sound. What sound? This. I am speaking, it is a sound. I am speaking, it is a sound. Now where will be vibration? I will come to the vibration. You observe sounds. You see, you cannot see, but you feel sound. I am speaking, it is a sound. Sound of birds, sound of vehicles, sound of peoples, sound of crowd peoples. All these are sounds. You observe different sounds. My sound will be heavy, will be, will be heavy. Sound of a girl, woman will be what? Thin, will be thin. Yes, you can observe also what different sounds from your daily life. In your life, there are a lot of sounds, and about those sounds we are going to explore in this slide. Did you understand? So here it is clearly showing you, telling you that production of a sound. What will be production of a sound? To produce something, what will be production? Yes, first vibration. First vibration. Vibration will produce. Vibration will produce a sound. I am speaking. It is a sound. Where is vibration? If I am telling you vibration will produce a sound, then tell me. You would say, tell me where is the vibration in this case in which you are speaking. So where will be vibration? Yes, here. This is known as a vocal cord. Vocal cord where vibration happens. Vibration happens. So yeah, vocal cords vibrate to produce a sound. To produce a sound in humans. In humans. So in humans, there is a found what? A vocal cord. In human, vocal cord is a found, and vocal cord vibrates here. Here is a what? Vocal cord, and it will vibrate, and that's why we are able to speak. We are able to speak. Clear? So remember, sound is coming from somewhere. It means vibration is happening. Vibration is happening. That's why sound is coming from somewhere. If I hit if I hit a rod with iron, then what will happen? Sound will come out. Sound will come out. And at the same time, you will realize vibration. Vibration. At the same time, you will realize what vibration. Did you understand? While Coco here vibration will produce what sound, and vibration in human where is it found? In vocal cord. Vocal cord vibrates to produce sound in human. This is one production of a sound. Now propagation of a sound. Propagation of sound. I am drawing something from which you will understand. This is a propagation of a sound. In this, you will observe particles. Here, propagation of a sound. Let's understand. It is a propagation of a sound. Even you can say wavelength. This is a wave. This is what? Wave. Wave of a sound. Wave looks like this. You can represent like it like that. It is a what? Wave. It is also wave. But in reality, you would see propagation of sound will look like this. Here, these are particles. A small. These are particles. When vibration will happen, then you will observe what propagation of a sound. Propagation of a sound. In propagation of a sound, there will be what? A lot of particles. A lot of particles. Remember, in propagation of a sound, this area where particles are more. In propagation of a sound, where particles are more, then that area we will consider as a compression. As a compression. Always write. In propagation of India, no India, in propagation of a sound, where particles are more, if particles area where particles are more, that area will be considered as compression. Now, what about a rare fraction? Rare fraction, not a rare fraction. Rare fraction. It is clearly telling you empty area, not completely empty. Some, some particles, some particles. This is not thick. This is not thick. Some particles. This is a more particle. This is a less particle. So less particles area will be considered as rare fraction. Rare fraction. Clear? Diagram of this can be like that. It is a way. It was also way. We will explore this. This is known as height, altitude. You can say crust. All this we will understand. Middle point. Not this. This middle point. Downward, upward. We will understand. We will explore this. This, okay? Middle line. So remember, compression is the area where particles are more, and refraction is also area where particles are less. Now to propagate, to propagate requires a medium for propagation. There is a one object, then we will take another object to propagate. Then you will get wave of a sound. Then you will get propagation of a sound. Propagation of a sound. Now here, yes, always remember, it is a single object. It is a single object. Now I am using my hand. It will be what? Another object. Now you can say, as I do like that. So here you will hear sound. You are hearing, you are listening sound. This is a sound. Now, as the sound comes out, there will be individual propagation of a sound. In where particles will move like that. Sound is coming from somewhere, it means vibration is happening. There will be propagation of a sound like that. Particles will move like that. When a object is hit by other object like that, so here particles will be disturbed. Particles will be disturbed. As I do, then sound is coming, vibration is happening. Now particles are moving like that. Yeah, I know we cannot see directly. We have to observe. Some particles will be more, some particles will be less. Some particles are more is what? Area where particles are more is a compression. Area where particles are less is rarefaction. We were understanding that for propagation requires a medium. Medium will be offset. Now, can propagate through solids, liquids, and gas. Object can be liquid, solid, or gas. Yes, in gas you can observe propagation. When something comes from a sky, you will listen. You will listen, not completely. you can hear what some voice from that object, that object which is coming from a sky. There will be what? Propagation. There will be sound, little sound. So it can propagate through solids, liquids, and gas. Clear? Now next is human ear. Human ear. Let me draw a figure of human ear. Are you visible to see this? Are you visible to see this? I am drawing figure of human ear. This is complete figure of a human ear. Let's see what is the work of Pena, what is the work of this, that. There are middle and inner part. There are three parts. First is outer, second is middle, and third is inner. Let's start from outer part of ear. In outer part you will have what? Pinna and ear canal. Pinna, work of a pinna will be work of a pinna is to collect that sound. Work of pinna is to collect sound. This part, this whole part is a pinna. Is a pinna. It is said that there is no bone and here there is no bone. I don't know here. But here, understand, work of a pinna is to collect. Work of a pinna is to collect a sound. Sound which is coming from somewhere. So who will collect? Pinna will. Pinna part of the ear will collect. Are you understanding? This is the first. Now next, ear canal. This pipe, you can see this pipe is a ear canal. Now what is the work of this ear canal? Will allow, ear canal will allow, not allow, you can say sound will go throughout the ear canal. Sound will come here and then it will go throughout the ear canal. Okay, so you can say inner canal will allow sound to come throughout itself. Clear? So this is pipe where sounds enter. When now we explain what this do, which is in outer area. Now, as the sound will enter through this inner canal, it will meet to the eardrum. This eardrum is what? Here will happen what? Vibration will happen. Here vibration will happen. Like that. Vibration will happen here. Eardrum will vibrate. Eardrum will vibrate to produce a sound. I think no to produce sound, but it will vibrate. And when eardrum will vibrate, because the sound is coming, that's why eardrum will vibrate. Somebody is disturbing to eardrum. That's why it will vibrate. It is happening because of other medium is coming, and other medium is what? Gas. Propagation wave in which there are particles. It is what? It is a gas. So here sound is coming. Sound will hit on eardrum. So here this process will be what? Propagation. Vibration. This process will be vibration. Eardrum will vibrate. Clear? Eardrum will be in middle part. Now, cochlear and auditory. It is said, I don't know clear, that when eardrum will vibrate, then cochlear, this part will give a signal to our mind. Will give signal to our mind. So work of this part is to provide information from here to our mind. So whatever will happen here in middle part. So this this part will provide information to our mind. Whatever will happen. Clear? So who will give signal? This part will give signal to our mind. Eardrum, work of eardrum is to vibrate. Work of ear canal is to allow upcoming sound. Work of a pinna is to collect the sound. Clear? Pinna and ear canal is in outer area. Eardrum and cochlea is in middle, and auditory is in inner. Clear? We can also write work of eardrum is to propagate. Yeah, work of eardrum is to propagate. Here we understood works of a human ear. We understood works of parts of a human ear. We human hear sound. How? Because of this ear. We can see anything. How? Because of we have eyes. We can smell anything. How? How is it possible? Because we have noise. We can eat something, which will be we can eat food. How? How it became possible? Because of we have mouth. We can do something. How? Because we have hand. All these are parts of our body. Same human ear is a part, and work of human ear is what? We can hear. We can hear because of human ear. Clear? So from human ear, from ear we hear, we hear, we hear. Okay. From eye we see. From hand we do something. Now next thing that I wanted to tell you. Now we will understand this. We will understand this. What do you think about the wave of the sound? Do you think it is a wave? Yes, it is a wave. You are right. Now, wave of a sound can be represented like this. Wave of a sound Wave of light. Do you know how to represent wave of light? Even I completely don't know. But wavelength of light is that it is the same. Okay. Now you remember there is a wave of a sound. How to represent? Like that. You have to represent like that. Wave of a sound. In this let's explore something forms. Here remember this height is what? It will be considered as amplitude, or you can consider it as a height. Amplitude. Amplitude, it is also known as a height. Now, wavelength. I cannot say that it is a wavelength. No, it will be wrong. It is a wave. Okay. Now here, this surface, upper surface of a wave, will be considered as wave crest. This top upper surface. With this top upper surface will be considered as wave crest. What about downward? What about down surface? This surface we will consider as wave top. Here, between two wave crest, wave crest will be wavelength. Clear? Also, but one point more I would like to add. Between two wave top, a space between, a space between two wave trough will be wavelength. How to identify all this in this? Here you can see this is a wave crest, this is wave crest. So a space between them is what? This. From here to till here, we will consider this as a one wavelength. So it is a wavelength. This is what? Wavelength. So definition of a wavelength, it is not a definition. We are saying where is wavelength in wave. So we would say it will be a space between two wave crest or two top. Clear? Yes. Here also you can say between these two wave top, this is what? Wavelength. This is wavelength. And we will consider this wavelength as a one. This is one wavelength. How much? 1, 2. 2 wavelengths. 1, 2, 3, 4. 4 wavelengths. So wave crest is what? Wave crest is a surface of it is a upper surface of a wave. Wave top is what? It is a lower surface of a wave. Amplitude is what? It is a height. From the middle line to the wave crest. So where is amplitude in wave? In wave of a sound, it is a amplitude from the middle line to the wave crest. Clear? Now what about this? These are formulas. Formula of sound. Here, what is the meaning of a frequency? frequency. What do you think about it? What do you think about it? Frequency is just a number of something. It will tell you number of something, but here we are in the context of a sound. It will tell you frequency of a wavelength. What is the number of a wavelength? In 1 second there will be only one wavelength. In 2 seconds, how much are frequency of wavelength? You would say two wavelength. Clear? So here you will consider frequency as a number of a wavelengths. 1 upon time period. 1 upon time period. Time period. How much number of wavelengths is taking time? How much time number of wavelengths are taking? If there are two wavelengths and two wavelengths took 4 seconds, so 4 seconds is the time period. Number of 4 wavelengths took 10 seconds. So you, like that you will represent 10 seconds will be what? So here frequency you will write what? 4 wavelengths. Time period 10 seconds. Like that. Okay. And here you will observe a speed of wavelength, a speed of this wave. That's why a speed will matter in this context. Here you will observe a speed of this wave of a sound. Clear? In 1 second, no. In 2 seconds, in 3 seconds. In 3 seconds, wavelength passed how much? How much? You can say 10 wavelengths. Whereas in 5 seconds, wavelength passed only how much? 2 wavelengths. So which one is faster? In 3 seconds. In 3 seconds, 10 wavelengths, let's say 10 wavelengths. In 2 seconds, in 4 seconds, same wavelength. Now you can easily tell what is the speed of both. Which one is faster? Which one is slower? You would say this first is faster. That's how you will observe a speed. That's why a speed will matter in sound chapter. Okay. To find out the frequency, just write 1 upon time period. To find out time period, just write 1 upon frequency. 1 upon frequency. Frequency, it means frequency multiple time period will be equal to 1. Frequency this multiple time. For example, frequency is 10 multiple 3 will be equal to 1. 10 3 is 30. 1. What is that? Here frequency is 10 and time is 3. No. What I am telling you, to find out a frequency, what time is it? To find out, we don't know frequency and we know what time. So we will write like that and we will get what? 0.33. In this, this is a frequency. This is a frequency of wavelength. Time taken by this frequency of length was how much? 3 seconds. Clear? That is how you will solve. To find out the time period, you know frequency. If you know frequency and you want to know time period, So what do you know about frequency? Frequency is a 10. Frequency is a 10. Now what will happen? 0.1. 0.1. Time is how much? 0.1. In this second, this much frequency passed. In this second, this much frequency of wavelengths passed. That is how you will solve numericals related to sound. These were formula of sound. Now next. Next is what? Always remember frequency ऐसा unit of wavelength और frequency will be hard okay, hertz. From this we will understand something. Before that, these are graphs. These are graphs. Here, first of all, let's try to understand this. It is telling you audible sound from 20 hertz till the 20,000 hertz. We can listen. We can hear sound of 20 hertz, from 20 hertz till the 20,000 hertz. That's it. Below the 20 hertz we cannot hear anything, any sound. Above the hertz of 20,000, our ear can damage. That's why it is said that between 20 hertz and 20,000 hertz we can hear sound of this much hertz. Okay. So from 20 hertz till the 20, between this hertz we can be able to hear anything. From the 20,000 hertz, ultrasound, it will be considered as ultrasound. Hertz which will be above the 20,000, it will be considered as ultrasound. I don't know who can hear this much sound. Infrasound, like an elephant can hear sound of below 20 hertz. There are some animals who can hear sound of below 20 hertz. There are some insects or animals who can hear sound of above the 20,000 hertz. When I say hertz, this much hertz, it means I am telling you sound is this much, sound is this much. When I say hertz, if I say hertz is how much? 50. So it is not a very high. It is a normal, you can say. It is a normal, not very high. When I say 10 hertz, then you can understand that sound is very slow. You will say that sound is very slow. When I say hertz is how much? 90,000 hertz. Sound of this is how much? 90,000 hertz. Then you will understand, oh, this much sound is coming from this device. That's how you understand. So here we are expressing number of sound in mathematics. For example, 20,000 hertz, 20 hertz, like that. So it is a 20 hertz is a sound, is a number of a sound. It is a low. 20,000, it is a high sound. Now we have understood this. What about this pitch? Always remember, pitch will depend on wavelength, a space of wavelength. Pitch will depend on wavelength, and loudness will depend on amplitude. It will depend on amplitude. Okay, but pitch will depend on wavelength. If wavelength, you can say length of wavelength. Yes, you will observe length of wavelength. If length of wavelength is what, how much? Is less, very less. In this graph, you can see length of wavelength is less as compared to in this. So if length of wavelength is less, there will be high pitch, and this pitch will be high because of wavelength is length of wavelength is less. Now in this pitch, length of wavelength is more as compared to this pitch. So if length of the wavelength is more, then there will be low pitch. Very low. You can say it is for us. High pitch it is for women. High pitch. Okay, did you understand that pitch will depend on length of wavelength? Now here, loudness. To find out loudness. Sound is slow, sound is low, sound is low, or sound is high. We can find from this diagram. If amplitude height if amplitude is how much is more, amplitude is more, you can say sound is high, sound is high. If amplitude is less, you would say sound is soft, sound is soft. If amplitude of the wave is less, sound will be soft. If amplitude is more, then sound will be loudly, sound will be more, sound will be high, you can say. Clear? There is a huge difference between loud sound and high pitch and loud sound. You understand? Pitch will depend on length of wavelength, and this loudness will depend on amplitude. Clear? Clear. Should I erase it for the next concept? Yes, we have some questions. You read this question? I wrote this question. Okay. One option I wrote. This is complete question. What is it telling you? Question is asking, you have given instruments. You have given instrument. You have to identify which one option is correct. If you are thinking this option is correct, this option is correct, then tell the result. What will you identify? You will identify that Dholak has this part to vibrate, has sitar this part to vibrate. If yes, then. So here we are going to see parts of a given instrument from which they can vibrate. Here this is instrument, this is instrument, this is instrument. This is part which will vibrate. But Dholak has membranous part. Okay. Sitar does not have air column. It has what? Strings. Sitar has a string. So here flute has strings, but as you know, flute does not have strings. It has what? Air column. So this decorated one option is incorrect. Now B option, it is telling you Dholak has air column. No. This is also incorrect because Dholak has membrane. Sitar has string. Flute has air column. This is B now, which is correct. So here, third option, Dholak has air column. This is also incorrect. Now Dholak has membranes here. This is correct. This instrument has strings here, string like that. When we play sitar with help of a string like that, so string vibrate. Strings vibrate. That's how sounds come out. And flute has air column. It is an empty, you can say, empty space. But this is a part where vibration happens. So answer would be this. Dholak was instrument. This was also instrument. This was also instrument. But membrane was a part of this Dholak. String is a part of the sitar. Air column is a part of a flute, from which this part vibrate. To produce sound. Clear? So answer would be B. Now next question. This is a very easy question. You can answer it. It is asking, sound cannot travel where? With this object, with which object sound cannot travel? You know, sound can travel in wood. Sound can travel in water. Sound can travel in air also. Vacuum, which means empty. Vacuum means totally empty space. Air has no particles. Air has a particles. We cannot say air is a empty space. It has particles. Vacuum, which means empty area. So there is empty area. Then sound. How can sound travel in empty area? No, it will be impossible. To travel sound, we should have object. We should have object. Object can be liquid or liquid or solid or gas. As you can see, wood is a solid, water is a liquid, air is a gas. Vacuum, there is nothing. So in this type of objects, the sound can travel. In solid object, the sound can travel. In liquid object, sound can travel. In air, in gas objects, sound can travel.